Okay, so I want to do another example which shows what happens when things get a little bit trickier and what to do about it. So here we've got another implicit function y defined in terms of an input variable x, and we want to find y prime. So we're going to start out, the general flow, this is going to be exactly like our last example. So we're going to start by taking the derivative with respect to x of both sides. So the left-hand side, sine of x plus y, that's going to equal the derivative with respect to x of the right-hand side. So that's our first step. Just, well, identifying what we're going to do, and now we're going to carry it out. So let's take a look at the left-hand side. We've got sine of x plus y. So what's the outside function here? The outside function is sine. So that's the one we're going to differentiate first, and we'll leave the rest to the chain rule. So what's our inside function? Our inside function is x plus y. So let's write this as our derivative is going to be cosine of x plus y. So leave the inside function alone, but we differentiated the outside function, right? But then I have to multiply by the derivative of the inside function. So I have to multiply by the derivative of x plus y. Okay, so that's the chain rule applied to the left-hand side. On the right-hand side, well, now we've got a product, right? Y squared is one of the factors, and cosine of x is the other factor. So let's write out the product rule. So we want the derivative of y squared multiplied by cosine of x. And then that's the first term of the product rule. And the second term of the product rule is going to be y squared times the derivative of cosine of x. So really all I did is just write out the chain rule on the left-hand side and write out the product rule on the right-hand side, and that's what gets me this equation. So what are we going to do on our next step? Well, we're going to dig into these smaller derivatives, right? The derivative of x plus y, well, it's addition, so you can break it up and do it term by term. Derivative of x is just 1, and the derivative of y, well, it's just the derivative of y. We don't know what it is, so we're going to write that one down symbolically. So the next step, we're going to have cosine of x plus y multiplied by this derivative 1 plus y prime, right? Because that's the derivative of y is y prime. So that's the left-hand side. Now there's no more derivatives left. That's done. Now on the right-hand side, we've got to differentiate y squared. But remember, we're talking about, all of this is with respect to the variable x, right? When we go up to the first step, we took the derivative with respect to x. So when we differentiate y squared, we're not differentiating with respect to y, we're differentiating with respect to x. So you have to treat y as an inside function. So we have to handle it with the chain rule. So derivative of the outside function and leaving the inside function alone, that's going to get us 2 times y. But then by the chain rule, we're going to multiply by y prime. So that takes care of the derivative of y squared. Now, of course, we still have the rest of this. We still have the cosine of x multiplied onto that term. Okay, now the second term, we've got y squared, but now we're going to differentiate cosine of x. Remember the derivative of cosine of x? It's negative sine. So we're going to multiply this by negative sine of x. And notice I don't have to do the chain rule here because this is a function of x, and there's no inside function, it's just cosine of x. So there's no need to do the chain rule there. So that takes care of all of the derivatives. So now we need to get all the y prime terms by themselves and get all the other non-y prime terms by themselves. Now there's an extra step that's going to be involved here. Notice that on the left-hand side, this is completely factored, right? If I look at this whole thing, it's technically one big giant term, but it doesn't have y prime as a factor. But it's also not independent of y prime either. There's a y prime involved here, but it's not a factor of this term on the left-hand side. 1 plus y prime is a factor, but y prime is not. So that's not good enough. We need to have every term fall into one of two categories. It either has y prime as a factor, or it is completely independent of y prime. And this one satisfies neither of those. But that's okay. We can fix that by just expanding everything out. So just multiply the cosine of x plus y into the brackets. So multiply it by the 1 and then multiply it by the y prime. And this is what you're going to get. You're going to get cosine of x plus y plus y prime cosine of x plus y. What about the other side of the equation? Well, can we do anything on the other side of the equation to clean this up a bit? Well, the first term, just leave that alone. And over here, well, let's bring the negative out in front of the y squared. That just makes it, then those brackets around the negative sine of x won't be needed anymore. So this is 2y, y prime, cosine of x, minus y squared sine of x. So that's about as much cleaning up as we can do. Now it's time to separate the y prime terms from the non-y prime terms. And now notice, every term is either independent of y prime, like this one and this one, or it has y prime as a factor, like this term and this term. So we're good to go. So let's move the y prime terms over to the left-hand side of the equation. So I'll subtract 2y, y prime cosine of x, subtract that from both sides of the equation, and you're going to get y prime cosine of x plus y minus 2y, y prime cosine of x. So that's the left-hand side of the equation if I bring this term over to the left-hand side. But this cos of x plus y, you'll notice I didn't write it down. That's because it's going to get subtracted to the other side of the equation because it doesn't have a y prime involved. So we're going to have negative cosine of x plus y minus y squared sine of x. So now we've got all the y prime terms together on the left-hand side of the equation. It's time to factor out y prime. So we can factor out y prime, and we're going to get the following. Y prime times, well, everything else, right? Cosine of x plus y minus 2y cosine of x. That's what you get if you factor out y prime from this term and this term. Okay, but on the right-hand side, nothing's happening, so we're just going to leave that term as it is, cos of x plus y minus y squared sine of x. So we're almost done. We just need to now divide both sides of the equation by everything in these square brackets. Right? We factored out the y prime. Now if we just divide this over to the other side, we'll have isolated y prime. So finally we can write y prime is equal to negative, this is the right-hand side of the equation, negative cosine of x plus y minus y squared sine of x, and that's all now going to be divided by cos of x plus y minus 2y cosine of x. Now, one thing, I mean, this is good enough. If you want to stop here, be my guest. Relax for a minute, but I'm going to go one step further because notice how there's the negatives on the numerator. Both of the terms are negative, so I could factor out a negative from the numerator and then factor out a negative from the denominator as well, which would, in a sense, it would change the order of the subtractions. Right? I'd have negative bracket 2y cos of x minus cos of x plus y bracket. That's what I would have if I factored out a negative. So I'd have the negative of 2y cos x minus cos of x plus y. So then if I did that, I'd have a negative on the numerator and a negative on the denominator, then I could cancel both of those negatives and I'd get rid of them. And what I'd have if I did that is I'd have almost the same thing, but it would just look a little bit cleaner, have a few less symbols, and just be a little bit easier to read. So it's worth doing. I'm going to write this as cosine of x plus y plus y squared sine of x, all divided by 2y cos of x minus cos of x plus y. And that is as good as you can do. So that is your y prime. So there was a bit of extra work to do right at this stage. We had to actually expand everything out. So if you're ever in doubt, if something ever seems a bit weird when you're at the stage and you want to separate the y prime terms from the non-y prime terms, and you have a term like this one where it doesn't seem to fall into either category, it's not independent of y prime because you see a y prime involved, but it doesn't have y prime as a factor either. So that signals to you that you might need to do some expanding. So when in doubt, just expand absolutely everything out, and that will take you to this stage where now every term either has y prime as a factor or it's completely independent of y prime. That's what you're shooting for. Then you're ready to start separating terms. Okay, and one last thing, if you're a little bit unsure of how I got from here to here, Just do it carefully in 2 steps. Factor out a negative from the numerator and then factor out a negative from the denominator. Then cancel them both and see what you get. And you'll see that you get exactly this. Okay, so I'll leave it as an exercise for you to check that. Now we have one more example on this page. And notice what's asked of us here is to find the second derivative of y. And we're given an implicit function here, x to the 4 plus y to the 4 equals 16. So we're actually asked to find the second derivative. And that might not sound like it's going to be that much more challenging, but actually these problems can get a little bit more complex when you're taking the second derivative. Imagine this one. Imagine in this example, if we had been asked to find y double prime, what would you have to do? You'd have to now take the derivative of this again, which is this is a monster now. So we're not doing it with this example, but you can see how it would get much harder if I was dealing with this example. But it's actually going to get more difficult with this one as well, but it won't be quite so unreasonable. So if you're asked to find the second derivative of a function, what do you think the first step is going to be? Well, find the first derivative, because in order to get the second derivative, you need to take the derivative of the first derivative. So that's your first goal, is to find the first derivative. So we're going to start out exactly like we did the previous problem. We're going to take the derivative of both sides and start finding y prime. So we're going to take the derivative of the left-hand side, x to the 4 plus y to the 4, and that's going to equal the derivative of the right-hand side. Okay, so on the left-hand side, we're going to differentiate each of these terms separately. The x to the 4, differentiate x to the 4, and you're going to get 4x cubed. Differentiate y to the 4, well, you're going to get 4y cubed. But then, of course, I need to multiply by the derivative of the inside function here. So I need to multiply by y prime. This is a pattern that seems to continually pop up, and that's going to happen early on in every implicit differentiation problem. Okay, and then on the right-hand side, well, this is always nice when this happens. You're taking the derivative of a constant. So it doesn't matter if it's 16, 11, or negative 35. If it's a constant, its derivative is 0. So that makes life a little bit easier. Okay, now we want to solve for y prime. So just move the 4x cubed over. So we're going to get 4y cubed y prime is equal to negative 4x cubed. All right, and then we'll just divide both sides of the equation by 4y cubed and isolate the y prime. So we're going to get negative 4x cubed over 4y cubed. So that is our y prime. Now, let's cancel those 4's. There's no reason we need to have those 4's there. That's just making it more complicated than it needs to be. So we've got negative x cubed over y cubed. Okay, but we're not done, are we? We still have to now take the derivative again, because this is just y prime. We want y double prime. So we need to take the derivative of y prime, take the derivative of this, which will be a quotient rule problem. We've got a numerator and denominator. They're both non-constant, so we're going to have to use a quotient rule. But that is going to be our next step. So y double prime now is, well, it's the derivative. Let's just write it in operator notation just to take a moment to clarify what we're doing. It's the derivative with respect to x of negative x cubed over y cubed. So that is what we're going to do. And how are we going to do it? Well, it's a quotient rule, like I said, right? So let's write out the quotient rule. We want the derivative of the numerator. So negative x cubed and with a square bracket prime. So that's the derivative of the numerator multiplied by the denominator unchanged minus the numerator unchanged multiplied by the derivative of the denominator, y cubed. And then remember, all of that is divided by the square of the denominator, which is going to be the square of y cubed. So that is the quotient rule. But there's still plenty of work to do. Right? We have to differentiate x cubed inside this derivative, and we got to differentiate y cubed. So there's still more to do. And I'm getting down to the bottom of the page, let's make some more space up to the right. Let's just move up here. Okay, so negative x cubed, take the derivative of negative x cubed, you're going to get negative 3x squared. Right? That's the power rule applied to negative x cubed. and then the y cubed is still there. And then what else can we do? Negative x cubed. Let's combine those negatives and write plus x cubed, just to make it a little bit easier to read. And then the y cubed that's getting differentiated, that's going to be 3y squared, right? Because using the power rule. But here we've got y. We've got an inside function y here. So we have to multiply by its derivative using the chain rule. Okay, so that is our new numerator. Now all of that is going to be divided by, well, y cubed squared is y to the 6, because you're going to multiply the 2 and the 3. All right, so there's a lot here, and we're not done, because there's something that you might notice here. Y prime, in the previous example, y prime was dependent on two variables, x and y. Right, x shows up a few times and y shows up a few times, but those are the only two variables that y prime is dependent on. And in general, that's what every derivative should only be dependent on. You should never have to have your y double prime being dependent on x, y, x, y, and then y prime. We don't want that. Okay, but the good news is we can get rid of it, because we know what y prime is in terms of x and y, right? Y prime is negative x cubed over y cubed. So we can substitute this fraction in for y prime, and then we can make this completely dependent only on x and y, and that's going to be our goal. However, as you can probably imagine, that's going to get pretty messy, because this is a fraction now. It's going to be put in here, and that's only now going to be one small part of the entire numerator of another big fraction. So it's going to get messy when we plug this in. So the idea is, let's simplify this as much as we can first. So factor out everything we can. Notice we can factor out a 3, right? There's a 3 in both terms. We can factor out an x squared, because there's x squared here and an x cubed here. We can factor out a y squared, because there's y cubed here and a y squared there. So we can factor out all that. And since the leading term is negative, let's factor out a negative as well. So here's what that's going to look like. And we'll go through this carefully. But it's going to be, if we're going to pull out negative 3 x squared y squared. Okay, so let's carefully work out what's going to be left. For the first term, we've pulled out everything except one of these y's, right? The negative 3, the x squared, and the y squared got pulled out. That just leaves us with one y. So we have one y. What about the second term? Well, first of all, we pulled out a negative, and this term is positive. So to fix that, we're going to have to put a negative here. That way, when this negative gets multiplied with this negative term, it'll change to positive, as you see there. So, well, what else now? We had an x cubed, but we factored out an x squared. So we're going to have 1x left. That 3 got pulled out. The y squared got pulled out. All that's left is the y prime now. So we're going to have y prime like that. And that's all over y to the 6. And, well, we could plug the y prime in. Let's reduce this a bit too. Let's say we got y squared and a y to the 6. Let's cancel the 2 of the y's. And I'll sneak it in here. We're going to have negative 3 x squared y minus xy prime, and that's all going to be over y to the 4 now. Okay, well, let's do this in the most painless way we possibly can. We still need to plug negative x cubed over y cubed in for this y prime. But let's just take a look at these brackets here. This y minus x times y prime. Let me carve out a bit of space here. We've got y minus xy prime. Let's just divide some space out so we can work just that out on its own for the moment, without having to carry this whole fraction with us every single step. So y minus xy prime, so just the part that's in brackets, what's that going to look like if we plug in the negative x cubed over y cubed? Well, that's going to be y minus x times negative x cubed over y cubed, right? Just literally writing it down. Now what's going to happen? That negative and that negative are going to cancel, and then that x can be multiplied onto the numerator, and that's going to change the x cubed into a y, or an x to the 4. So we're going to have y minus, or plus actually, plus x to the power of 4 over y to the power of 3. And well, we can, because we're going to have to merge this with another fraction, we don't want this format where we've got a y, which is not a fraction, added to something that is a fraction. So let's get a common denominator and combine this all into one fraction. So if I multiply the y by y cubed over y cubed, I'm going to end up getting y to the 4 plus x to the 4. This will be all over y cubed, and this is still over y cubed, right? And now that they both have the same denominator, so I can add them together and get y to the 4 plus x to the 4 over y to the 3. And that's actually a lot better. That is a little easier to plug into and remember, this has to just take the role of these brackets. It's not, this is all of y minus xy prime. But actually, it gets even better. There's one more thing we can do that even still significantly simplifies this even more, and it's not obvious at all, especially when we've been focusing on all the details down here. It's been a while since we've actually looked back up. What is the original equation that defines a implicit function? Well, the function obeys this relationship. X to the power 4 plus y to the power 4 is equal to 16. Well, guess what you have in your numerator here? Y to the 4 plus x to the 4. Well, it's the same as the left-hand side here. The terms are just added up in the other order, right? So that's really, this is x to the 4 plus y to the 4, which is supposed to equal 16. So we can even simplify this even further as 16 over y cubed. And that makes your life even easier. So let's take that now, 16 over y cubed, and plug that. What was this? This was the y minus xy prime. So this fraction here is going to take the place of all those brackets. So let me just block this off. So really what we have now is negative 3x squared times 16 over y cubed. Now, and all of that is divided by y to the 4. Okay, so what's going to happen? We've got a fraction in the numerator. Really what's going to happen is that y cubed is going to be adjoined to the numerator through multiplication. So what we're going to have is, I'll do this over two separate steps so it's a little easier to follow. We'll have negative 3x squared multiplied by 16. So the y cubed really gets detached from the fraction up top and gets merged with the denominator, and you get y to the 4 times y to the 3, which is equal to y to the 7. Okay, and then that, well, now we can merge these two constants that are multiplied, the 3 and the 16. That's really going to be 48. So finally, you have negative 48 x squared over y to the 7. So that actually simplified significantly, right? That is so much simpler than this form up here, right? So it was worth taking the time to do that. So anyways, that is our second derivative. Finally, we got our y double prime.